Hello, my name is Rab Bennetts. I'm an architect, and most of my firm's work is in the non-domestic sectors, such as offices, universities, theatres, public buildings, and so on, such as Edinburgh University's Futures Institute and the Citizens Theatre in Glasgow. Now, we've been carrying out environmentally friendly buildings for nearly 30 years all over the UK. Now, targeting net zero carbon in buildings like these means measuring and greatly reducing the emissions for the whole of a building's life. And that really comes in three parts. The first part is the embodied carbon, which is produced by the actual construction processes. The second part is the operational carbon produced by the building in use, which of course could be for the life of 50 or 100 years or more. And the third and last part is the embodied carbon produced by demolition, or reusing the building for another function at the end of its first life. So taking each one of those in turn, the carbon from construction is, I guess you could say, an elephant in the room. It's because it's completely unregulated at the moment. It comes from all the new materials from their original sources through manufacture, delivery and erection on site. But it also includes maintenance because, of course, you have to replace things like carpets over time. Now, these can exceed the lifetime carbon emissions from the operation of the building, and that's not generally understood. But it is unregulated. It is extremely difficult to reduce without a big change in the way we do things. So the first question we need to ask is, do we need a new building at all? Can an existing building be retrofitted or extended instead? Now, whether or not it's a refurbishment or a new build, materials and assemblies should be as low carbon as possible. And I'll give you a few examples. Using biogenic materials, which is things like timber structures instead of concrete and steel. Avoiding high cement content in concrete and plasterboard. Using recycled materials such as steel instead of completely new. Sourcing materials like aluminium from hydro-powered plants, as you get in Scandinavia, instead of other parts of the world. Avoiding petroleum-based products, which is things like plastic and nylon in carpet tiles. Obtaining materials locally to avoid excessive transport emissions. So this is an amazing subject. It's incredible how much in the UK construction industry comes from all over the world. We need to change that. And on the last on this little section is assembling as much as possible in factories off-site to reduce waste, reduce defects, reduce accidents, and reduce the amount of manual labour on site. Now, the second subject, of course, is operational carbon from the building in use. And this is much better understood. It comes from things like heating, cooling, lighting, the lifts in a multi-storey building, and they're already regulated. However, the emissions from the users are on top of these and represent a large proportion of the total, but are currently unregulated. They come from things like computers and server rooms in offices, production lines in factories, technical equipment in theatres, canteens in schools and universities. Now, carbon-free renewable energy is increasing rapidly, but it'll never meet these needs unless we reduce the demand for energy at the same time. And I'll give you a few examples of those. Obviously things like we have to change from gas boilers and generators to heat pumps that work off renewable electricity. But we need to design to reflect cooler local climatic conditions in Scotland, whereas the international conventions at the moment promote office buildings that have air conditioning, for example, as if the standards were the same throughout the world. Increasing thermal insulation and solar control reduces both heating and cooling. Opening windows for natural ventilation where it is sensible to do so. Now again, there's a caveat here because Scotland's climate is on the cool side, so opening windows can be wasteful during cool weather, and mechanical ventilation can be more efficient overall because you can reclaim some of that heat. We need to maximise good daylight to reduce artificial lighting, and we need to specify simple and robust services systems and control systems that are easy to understand and operate. Now, many of these examples will actually result in buildings that are more pleasant and comfortable to occupy, so that it really is a win-win situation. The last subject is this carbon from demolition and reuse. And now new buildings should now be designed to support what we call the circular economy. And that means, for example, creating adaptable building shapes that can be converted to other uses in future. Using standardized components such as structural frame, beams and columns, partitions and many finishes. We should design connections, junctions and dry construction that allow for dismantling, and we should be using materials that can be recycled. So it's simple but very effective stuff. Now, all of the issues I've been describing here can be measured and should be measured with scientific rigor and honesty. For example, it's no good claiming that an energy efficient new building is zero carbon if the embodied carbon is excluded from the calculation, which is what's happening at the moment. So what we need to do now is roll out the existing targets for operational and embodied carbon devised by bodies like the UK Green Building Council, so that everyone has a route to net zero carbon. We need to create carbon targets for the users of buildings, as these activities are not currently regulated. Now, this may have some impacts on personal freedoms and lifestyle choices for all kinds of buildings, so it's not going to be easy. And last, we need to agree ways of offsetting carbon or introducing a carbon tax in the short-term period when zero is not yet achieved and we're still using the term net zero. Thank you for listening.